our sun, a celestial body that has fascinated humanity for millennia. It is a constant presence in our sky, a source of light and warmth that we often take for granted. But what lies beneath its glowing surface? A blazing ball of plasma, a churning inferno of nuclear fusion. The sun's core is a furnace where hydrogen atoms fuse to form helium, releasing an immense amount of energy in the process. This energy travels outward, eventually reaching the sun's surface and radiating into space. It is the lifeblood of our solar system, bathing us in light and warmth. Without the sun, our planet would be a frozen wasteland, incapable of supporting life as we know it. The sun's energy drives the weather, powers the water cycle, and sustains the delicate balance of ecosystems. Life on Earth, from the smallest microbe to the largest whale, owes its existence to the sun's energy. Plants harness sunlight through photosynthesis, converting it into chemical energy that fuels the food chain. Every living organism, directly or indirectly, depends on the sun's rays. But our sun is not always benevolent. It is a dynamic and sometimes volatile star, with a cycle of activity that includes periods of intense solar storms. These storms are driven by the sun's magnetic field, which can become twisted and tangled, leading to explosive releases of energy. It has a violent side, capable of unleashing immense bursts of energy that can reach across millions of miles of space. These outbursts, known as solar flares, are sudden and intense eruptions of radiation. They can release as much energy as billions of atomic bombs. These outbursts, known as solar flares, are a reminder of the raw power that lies at the heart of our star. Solar flares are often accompanied by coronal mass ejections, CMEs, which are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. While most solar flares are harmless, some can disrupt our technology here on Earth, interfering with radio communications and GPS signals. High-frequency radio waves can be absorbed or reflected by the ionosphere, leading to blackouts and navigation errors. But what if the sun unleashed a superflare, an eruption thousands of times more powerful than anything we've ever witnessed? Superflares are rare events, but they have the potential to cause unprecedented damage to our technological infrastructure. What would happen in the minutes and hours after such an event? The initial blast of radiation would reach Earth in just over 8 minutes, potentially causing widespread communication outages and power grid failures. Satellites in orbit could be damaged or destroyed, leading to a cascade of technological disruptions. The consequences would be profound, impacting nearly every aspect of our modern world. From the loss of satellite-based services like GPS and weather forecasting, to the potential collapse of power grids, a superflare could plunge us into a technological dark age. It is a stark reminder of our vulnerability and the immense power of the star that sustains us. Imagine a force so powerful that it could release the energy of billions of atomic bombs simultaneously. This unimaginable power is not just a figment of science fiction, but a reality that exists within our very own solar system. That, in essence, is a superflare. A superflare is an astronomical event that can unleash energy levels far beyond the typical solar flares we are accustomed to. These events are so powerful that they can be seen from light years away, marking their presence across the cosmos. These colossal explosions dwarf even the most intense solar flares, releasing a torrent of radiation and charged particles into space at nearly the speed of light. The sheer magnitude of a superflare is enough to alter the very fabric of space around it, sending shock waves that ripple through the solar system. While our sun is capable of producing such superflares, they are thought to be incredibly rare, occurring perhaps once every few thousand years. The rarity of these events does not diminish their potential impact, however. The sun, a seemingly calm and constant presence in our sky, harbors the potential for these cataclysmic outbursts. However, the possibility of a superflare striking Earth is not mere science fiction. Historical records and scientific data suggest that our planet has experienced the effects of solar superflares in the distant past. The Carrington event of 1859, the most powerful geomagnetic storm on record, serves as a stark reminder of the sun's potential fury. It is a very real threat, one that scientists are only beginning to understand. Researchers around the world are tirelessly studying the sun's behavior, using advanced technology to monitor solar activity and predict potential superflares. Their work is crucial in preparing for and mitigating the effects of such an event. The impact of such an event would be felt across the globe, disrupting our technology, our infrastructure, and potentially even our way of life. Modern society is heavily dependent on technology, from communication networks to power grids, all of which could be severely affected by a superflare. Let's explore minute by minute the unfolding drama of a superflare impacting Earth. Imagine the initial moments as the superflare's radiation reaches our planet, causing widespread communication blackouts. Satellites in orbit would be among the first to be affected, their delicate electronics fried by the intense radiation. As the minutes passed, the charged particles would begin to interact with Earth's magnetic field, creating stunning auroras, but also inducing currents that could overload power grids. The cascading effects would ripple through society, highlighting our vulnerability to the sun's immense power. This journey through the potential aftermath of a superflare will underscore the importance of understanding and preparing for these rare but devastating events. In the vast emptiness of space, a superflare erupts from the sun's surface, sending a surge of radiation hurtling towards Earth at the speed of light. For the first 8 minutes, our planet is blissfully unaware of the impending danger. The radiation, invisible to the naked eye, races towards us, carrying with it the potential to disrupt our technological civilization.
During these initial minutes, satellites orbiting Earth would be the first to feel the impact. The intense radiation would bombard their sensitive electronics, potentially causing malfunctions and disrupting communication networks. On Earth, however, life would continue as normal, oblivious to the invisible threat hurtling towards us.
Section 4, Minute 30, Peril in Orbit, Astronauts in Danger. Just 30 minutes after the initial eruption, the first wave of radiation from the superflare slams into Earth. This event marks the beginning of a series of catastrophic consequences that ripple through our planet's delicate balance.
Astronauts aboard the International Space Station, orbiting high above our planet's protective atmosphere, would be particularly vulnerable. Their position, while offering a breathtaking view of the cosmos, also exposes them to the harsh realities of space weather. The intense radiation could penetrate their spacecraft, posing a significant health risk and potentially leading to radiation sickness. The crew would need to take immediate action, seeking shelter in the most shielded parts of the station, but even these measures might not be enough to fully protect them.
Down on Earth, we would still be largely unaware of the unfolding cosmic drama. Life would continue as usual, with people going about their daily routines, blissfully ignorant of the invisible threat hurtling through space. The radiation, while intense, would be mostly absorbed by our atmosphere. This natural shield has protected life on Earth for billions of years, but it is not impervious. The upper layers of our atmosphere would bear the brunt of the impact. However, some of the radiation would begin to ionize the upper layers of our atmosphere, potentially disrupting radio communications and GPS signals. This ionization process could lead to a cascade of technological failures, affecting everything from navigation systems to power grids. The first subtle signs of the impending technological storm would be seen in the form of static on radio channels, dropped calls, and malfunctioning GPS devices. These disruptions, though seemingly minor at first, could escalate rapidly, leading to widespread chaos and confusion. As the radiation continues to affect our planet, power grids could become overloaded and fail, plunging cities into darkness. Emergency services would be stretched thin, responding to a multitude of crises simultaneously. Scientists and engineers would work around the clock, monitoring the situation and attempting to mitigate the damage. Their efforts would be crucial in preventing a complete technological meltdown. Meanwhile, the general public would start to notice unusual phenomena, such as auroras appearing in places where they are rarely seen. Communities would gather, seeking information and reassurance as the true scale of the event becomes apparent. For the astronauts in space, the ordeal would be far from over. They would continue to face the dangers of radiation exposure while also dealing with the psychological stress of being so far from home during such a crisis. The story of Peril in Orbit is a stark reminder of the fragility of our existence in the vastness of space. It underscores the importance of preparedness and the need for continued vigilance in the face of cosmic threats. Section 5, Hour 16, the Earth's magnetic shield under siege. 16 hours after the initial blast, the full force of the superflare arrives. The coronal mass ejection, a billion-ton cloud of superheated plasma, slams into Earth's magnetic field with immense power.
Our planet's magnetic field, a protective bubble shielding us from the sun's constant barrage of charged particles, is put to the ultimate test, facing unprecedented challenges. The impact of the coronal mass ejection would trigger intense geomagnetic storms, lighting up the sky with brilliant auroras visible even in daytime, a rare and spectacular sight.
These auroras, while beautiful, would be a harbinger of the disruption to come, signaling the start of a chaotic period. Power grids across the globe would surge and overload, potentially causing widespread blackouts, leaving cities in